Hello everyone and welcome to the channel. Whenever I do a fine-tuning video of a model, the most common question I get is around dataset, and I do understand the validity of that question because I also firmly believe that data is the cornerstone of any successful application, regardless of whether it is AI powered or not. This is more true when it comes to LLMs, whether you are fine tuning the LLM as per your own use case or you are simply doing retrieval augmented generation. Data is the key. In this video, I'm going to show you how you can create a data set from scratch for your own use case by using Ollama for free. One of the key thing you need to remember after remembering that data is the key for the success for your LLM application is that you don't really need massive amount of data to fine tune your large language model for your own use case. If your data set has around 1000 rows or so, that's more than enough. Yes, I'm not kidding. I'm telling you that you don't need hundreds of thousands of rows in your data set to fine tune your LLM. Now, before I show you how to create the data set, let me try to explain in simple words what exactly is meant by fine tuning. Look, all of these models which we see in our day-to-day life like Llama, Mistral, Zephyr, Phi, Gemma, all of these models when they get released or when they get created, they are called as pre-trained models or base models. What happens is that the companies like Meta, in case of Llama 3.1, they took data from across the globe, maybe from internet, from Wikipedia or wherever, just as an example, and then they train their model on that data set. So that data set knows a lot, but it's not an expert in anything. Especially it doesn't know about your own personal data or your own company's data. So if you ask an instruction or if you ask that model up something about your own data, it won't know, or sometimes it will just give you incorrect answer, which means it hallucinates. Now, in order to make a model to answer a question as per your own data, there are few things which you can do. Either you can do prompt engineering, where you just embed your own context of data into the prompt and then throw it to the model. But as we all know, prompts has limited number of space, and then if you just putting in stories upon stories in the prompt, that won't work. Second option is the retrieval augmented generation, where you throw your data into a RAG database after converting it into numerical representation. And then from there, the data is retrieved and then augmented with your prompt to give you better answer. So that is the second thing. But sometimes even that is not enough. In that case, the last option is fine tuning. Now there are a lot of techniques around fine tuning. We have full fine tuning where we just take the whole model and then retrain it on our own data. Then we have uh, LoRa, or maybe parameter efficient fine tuning is a better word because that contains LoRa, QLoRa, and few other techniques. So parameter efficient fine tuning means that instead of retraining the full model, you just uh, create some adapters after freezing the actual weights of the model, and then you put those adapters into model's hidden layer and then retrain those weights. So there are few other techniques in there, but the basic idea is that you try to give that model context your own data. Now that is all good and fine. We have a lot of techniques there which you can use to do the full fine tuning or lot of fine tuning. But the key here is, where do you get the data? So all of our organizations have databases, right? And most of our data is stored in our Oracle databases, SQL Server databases, MySQL, Postgres, and the list goes on and on and on. Now, you don't need to extract that terabytes of data from your database. Just extract some of the sample representative one, and that of course will depend upon your application, that what sort of application you have. So just extract 1000 rows from most of your major tables, and then from there, um, just create a data set out of it. And in this video, I'm going to show you how easily you can do that. I will also share the code with you which I'm going to use. I will put it in my blog and will drop the link to it in video's description. All you need to do is to just extract the schema of your database, right? And then uh, just get some sample 10 or 20 rows, put it in there, and then we will use it. So now let me show you how you can do this. As I mentioning Ollama. If you don't know what Ollama is one of the easiest and fastest tool to run large language models locally. I have done heaps of videos on Ollama, so please search the channel and you should be able to find it. So let's go to my local system and I will show you how to do it. I already have Ollama installed, by the way. Very simple to install. Let me also give a huge shout out to our good friends at Mast Compute who are sponsoring the VM and GPU for this video. If you are looking to rent a GPU on affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. So let me take you to my terminal. This is where I'm running Ubuntu 20.04 and this is my GPU card NVIDIA RTX A6000. Let me clear the screen. Now I already have Python installed. I already have Ollama installed. So if I do Ollama list, you see that I already have Ollama based Llama 3.1 model running and just present there. Again, if you don't have it, simply do Ollama pull Llama 3.1 and that's about it. And you will get Llama 3.1. Just I have it here. Let me clear the screen. Let me launch my Python interpreter. So first I'm just going to show you how you can create a data set, right? And then I will show you how you can create a proper file out of it so that you have multiple records. So let me take you through uh, pass by pass. Now, one more thing to remember here is that you would also need to make a selection of your base model or pre-trained model, such as in our case, we are going to use the Llama 3.1. But if you have any other model which you want to select, don't you can use it, no problems there. But remember that every model has its own prompt format. Format is that the way you ask the model a question. If you use the prompt template which is recommended by the model, you will get optimal response. So I would highly suggest that you use the prompt template accordingly. For instance, I have just defined this function which lets you give it user, system and assistant prompts, and then it creates a prompt template as per Llama 3.1, and it's a very standard one which you can get from Llama 3's website. Similarly, for example, if you are using Zephyr model from Hugging Face, it has its own chat ML prompt, and every model has its own. So you can use that one. So now if I just go through it quickly, user mean what you are asking, system mean the AI, the starting one, where we are telling model what it is supposed to do, and assistant means the model's response. So first we are checking if there is a system response, then put a header in front of it, give the system, and then end the header, and then this is where system will stop its end of turn or end of and it system will stop speaking. User will start again, start header user, and then user will finish speaking with end of turn, and then assistant will come in, and then after this you will just keep talking with assistant and assistant it which is going to return us the response. So this is what it means. Okay, now that we have done, now as a sample one, let me define my schema. So schema, if you're not aware of database jargon, whatever data structure is there in your database is called as a schema. So for example, maybe I have a table in my database for the movies, and this is the data which it contains. Like it has a, these are the number of rows, 0 to 6, 7 rows. There is a title there which is a movie title, and then we have the data type is text, and example is Inception, director is Christopher Nolan, and then this is the rating of that movie. So this is my column names and the example data, column names, example data, and the data type of that column. And you can define multiple tables here if your database has it. So just pick alter it as per your own database and then use it. So I have defined the schema now, and now let me start defining the prompt. So first let's so what I'm trying to do here, I'm just trying to create a data set where we will create a user's query that what user wants to ask, and then we will create a SQL query in response. Now, let me actually show you an example that will make more sense here. Let me put it in my VS Code, and this is where I'll show you as what we are trying to do here. Let me quickly take you to my VS Code. So this is my VS Code. Just don't worry about this, forget it. Just uh, focus on this line, question and SQL. So this is what we are trying to create here. That I'm just going to make it triple so that it won't give me error. Okay, so this is the data set I'm going to create, that there will be a question by a user and the model is going to create a query out of it. So text to SQL data set we are creating. So for that data set to happen, what I'm trying to do it, first I have defined a schema, and then I'm going to ask the model Llama 3.1, which is running on Ollama, to generate the question and also generate the query. And on the basis of the schema which I have given, which I already showed you where we have given it. So, and then I'm going to ask it to generate it a full file. It is going to generate like 30, 40, 50, 100,000, whatever you want. And then that data set we will use to fine tune our model. So the advantage is that data set will be right according to our own schema. I hope that you are getting my point. It will be more clearer once we see it in action. So now you know what the end result is. So this is what I am aiming to create with the help of the code which I have just showed you. Let's go back. So we have now defined our prompt. We have defined our model's schema. Let's now first define the system prompt. Okay, so for the system prompt, let me first paste it here and then I will show you what is happening. So let's paste it step by step. So you see, first I'm saying it, system, you're a data analyst with a 10-year of experience writing complex SQL queries. And then I'm just telling it, consider a table called movies with the following schema. And where is the schema? We already have defined a function around it. This is the one, get movie schema, and this is a get movie schema at the top. This one we have already defined. So now the model knows what is the schema. Here is. Next up, let's define the questions. So you see, the first I'm saying consider the following question and queries used to answer them. And then let's give it a sample. So models are sort of dumb. We need to give them, sorry, I just didn't. Let me properly do it. So it was just, okay, let me do it now. Oh, sorry. I think it is not copy pasting it. Okay, my apologies. There you go. So this is a question, and then let's give it a sample query out of it. There you go. So you see, I have given model an example that this will be the question and you need to create a query accordingly. And then let's paste it into the system prompt. This is how. And then let's also get a user query, that what user is supposed to ask. Something like this. The user is asking, write a question and a query that are similar but different to those above, which we have just shown it as an example. I am also asking it to format the question and query as JSON object, and then I am giving it the question and the query which we have defined above. And then I'm also instructing it, make sure to only return me valid SQLite query. But if you are using Oracle or SQL Server, you can change that to Oracle SQL Server. And then I'm asking it, generated as response to the question. Don't give me any comments. Just return questions and query as JSON objects. Make sure query is relevant to the question. Make sure each query is complete and ends with /n. Okay, that is good. And now let's call the function and see what model returns. And this is a function which we have defined above. Let's print it out. Let's see what it has created. There you go. So I've just printed this prompt here. It's a proper Llama 3 prompt. So this is a system prompt. We are telling the model what its role is. Then this is a schema, and then this is a sample question and query, right? And then this is a user's one, that where user is telling it what needs to be done. And then this is assistant done. Assistant will be the one which will be actually giving us the response. Now let's try to generate some sample SQL and question from the Ollama model. So let me make it a bit easier. I'm just importing Ollama, and then let's generate the result from Ollama. So you see here I'm using Ollama's 3.1 model, which is running locally, and our prompt which we have defined above. Let's wait for the result to come back. That is done. Let's try to print the response. There you go. So it's a new query which the model has generated with the question, what are the top 5 highest grossing sales, and then SQL query. How good is that? Right? Now, if you just want to extract this query from it, you can try parsing it if you like. For example, something like this. And then you can safely extract the question and query separately, like this. And then you can print both of them separately if you like, but that is what we will be using in our data set. There you go. So you see, this is a question, this is a query. How good is that? Now this is only one item it has generated now, but we want to create a full data set file. How do we do that? We can simply put it in a loop, and after generating a function out of it. I already have created the code. Let me take you quickly to my VS Code and I'll show you what I mean there. So this is my VS Code. If you see, it's the same code which I have just shown you, but little bit of uh, changes where I have put it in the loop. Let me walk you through. So I'm just saying import JSON Ollama, same Llama 3 prompt, then our movie schema, and then where we were just copy pasting it separately, I have just created a function on top of it, like generate question and query. Then same system prompt, user prompt, with the assistant one, calling the Ollama, getting the response, then getting the dictionary which I showed you, saving to JSON L format. JSON L format is primarily the format we create a data set where each JSON object is on separate line. And then this is our main function where we are calling the above functions step by step. I just want number of 10, that how many you want. You can put it 1000 here, but just for the sake of completion, I'm going with 10. It's a free model, no API charges, generate as many as you like. But as I said earlier, for your fine tuning, 1000 is fine. And then I'm generating it, it is just looping through it, and then it is going to save it and it is going to give the result back. So let me run it. Let me take you back to my terminal, and this is where I'm going to run it. So let me first exit, clear the screen. Let me do ls-ltr. I already have saved the code in that test.py. It's the same code which I just showed you. Let me clear the screen, and now let me run that code. Test.py, it is running, and what it is going to do, it is going to okay, I think I just put an extra file there, but that is fine. Let it run. Let's wait for it to finish. So you see it has saved 10 questions queries to JSON-L file. If you do ls-ltr here, you will see that now we have this file. Let me see if it has put it in anything here. Let me run it. And there you go. You see these, it has filled in 10 questions, 10 question and SQL query. This is a question, this is a query. This is a question, this is a query. So you see we have our own data set now. You can create 1000 rows here, and then you can just, all you need to do, you can use unslots, you can use axolotl. There are a lot of tools there. I just did another tool, you know, uh, just few days back, where it's a new tool. I skip its name is skipping my mind, but there are like dozens of tools which you can simply use to get your base model, whatever it is. Pick your data set like you have just created, throw it in the mix, and off you go. And just because you are using 1000 rows, you don't need a mega GPU. You can just fine tune it on Google's T4 free GPU if you like in the Colab. And of course, this Code is so lightweight, you can even run it in Colab. If you don't know how to run Ollama in Colab, I already have done a video on it. You can also check it out. So that's it, guys. I hope that you enjoyed it. Let me know what do you think. I hope that this was useful. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thanks for watching.